Hello viewers, and welcome once again. We are still under logic, Christ Almighty God's Algebra. Today we are going to treat Christ the Almighty God's grace. Christ the Almighty God's grace. Let us start. Christ the Christ the Almighty God's grace. P and Q is equal to not P implies Q is intensification of P and Q. This is a typical example of Christ Almighty God's grace. You see that this P and Q equal to not P implies Q is intensification of P and Q. In this equation, it is not logical equivalent, it's logical implication. That means it is grace. Since it's logical implication, it is grace. If it's logical equivalent, it means that it is law. In the sense that it's not a case that whenever P and Q is true, not P implies Q is also true. In the same vein, whenever not P implies Q, ID, right substitution, is false. Also, P and Q, ID, left side of the equation, is also false. It's not the case. It's case that whenever P and Q is true, not P implies Q must also be true. He said that it is an intensification of the antecedent. That means the question of the left side of equation. In the sense that P, not P implies Q is greater than. That means is a macrocosm. It's a macrocosm of P and Q. That means it is a superset of P and Q. And if it is a superset of P and Q, it means that it is greater than P and Q. That's why he said that not P implies Q, which is the superset, that means the macrocosm of this P and Q. He said it is intensification, it is increase in value of P and Q. That means it is the relation of P and Q. Now let us prove this statement that this statement is Christ Almighty God's grace. Proof. Suppose P and Q is equal to not P implies Q is intensification of P and Q. We assume that the statement is true, that P and Q is equal to not P implies Q is intensification of P and Q. That means it is also our hypothesis. So we are going to prove that it is true. You see that this P and Q equal to not P implies Q is a logical implication. It is grace in the sense that whenever P and Q is true, then not P implies Q is also true. That means not P implies Q is greater than the P and the Q. That will say is intensification of P and the Q. Since that is the case, we are going to transform it to conditional statement and it will still preserve truth. When transform it to conditional statement, it will still preserve truth, that means tautology. So if and only if P and Q implies not P implies Q. We have now transformed it to conditional statement. I said whenever this antecedent is true, the consequent must also be true. If that is the case, whenever we bring this statement, there's no possibility of getting falsity, always truth. You said that statement is tautology. Is tautology. Being justified by logical implication. We have treated logical implication in our previous tutorial. You can go back to our previous tutorial to be acquainted with knowledge of logical implication. So this is being justified by logical implication. By logical implication. If and only if P and Q, you see that this conditional statement is tautology. That means P and Q implies not P implies Q is tautology. Since tautology, you then know that this P and Q, the antecedent, is a proper implication of this not P implies Q. And if that is the case, we say that it is certain that P and Q exist. Since that P and Q exist, we say that P and Q is logical implication of not P implies Q. That means P and Q, the antecedent is logical implication of not P implies Q, the consequent. So is logical implication of not P implies Q. Since this is true, that this P and Q is logical implication of not P implies Q, also this also must also be true. So that if and only if P and Q is equal to P and Q. So it is true that logical implication is equal to itself. That means P and Q, which is the logical implication, is equal to P and Q, that the itself, and its logical equivalent. It says that whenever the left-hand side of the equation P and Q is true, also the right-hand side of the equation P and Q is also true. Also, in the same vein, whenever P and Q are the right hand side of the equation is false, also P and Q are the left hand side of the equation is also false. We say that it is logical equivalent. So it is true that P and Q is equal to P and Q. Being justified by identity. That means the sameness. Being justified by identity. If and only if P and Q is equal to not bracket, not P or not Q. You see that this P and Q has now been substituted with not bracket, not P or not Q. It is the logic, it's logical equivalent. They are logical equivalent. So substitute it with not bracket, not P or not Q. Being justified by the Morgan's law. By the Morgan's law. Being justified by the Morgan's law. If and only if P and the Q is equal to not bracket. Now let us transform. This is not P or not Q is in disjunctive statement. I'm going to transform it to conditional statement, and it will still preserve logical equivalent. It will still be law. That means that this and this is equal to P implies not Q. Being justified by first Ejike's law. Being justified by first Ejike's law. If and only if P and Q is equal to. Now let us signify this statement, not bracket, P implies not Q. What is my signification of this? That means to signify this statement, it means that the statement is going to be negated. If statement is positive, it's going to be negative. If it's negative, it's going to be positive. So the statement is negative. That means P implies not Q is negative. Now it's going to be positive. And this statement here, every statement also going to also be negated. In this, so since this P here is positive, it's going to be negative. And this not Q is negative, going to be positive. That means we have this statement now is now negative, it's going to be positive. That means it's now not P implies Q. You see that it's no more logical equivalent. It's no more logical equivalent. The right hand side of equation now is greater than the left hand side of equation. So, and the right hand side of equation is a superset, is a macrocosm of the left hand side of equation. He said that now the statement has now been intensified. It has now been now intensified. He said that is intensification of P and the Q. So he said it's intensification of P and the Q being justified by signification of law. By signification of law. By signification of law. Being justified by signification of law. We have now proved that P and Q is equal to not P implies Q. Is the description of P and the Q. We then conclude. You say thus P and Q is equal to not P implies Q. Is intensification of P and the Q. We are going to prove the converse so that by the principle of intentionality, we can establish that not that P and Q is equal to not P implies Q is intensification of P and the Q. We have done principle of intentionality in our previous tutorial. So we can go to our last tutorial to be acquainted with principle of intentionality so that you understand or know more about principle of intentionality, which are going to use to establish that P and Q is equal to not P implies Q is intensification of P and Q. Conversely, conversely, not P implies Q is equal to P and Q is extenuation of not P implies Q. So this is a converse of P and Q equal to not P implies Q is intensification of P and Q. So the converse is not P implies Q equal to P and Q is extension of not P implies Q. Equal to this side. So suppose not P implies Q is equal to P and Q is intensification of P and Q is extension of P and Q is extenuation of P is extension of P and Q. Now we assume that the statement that means this not P implies Q equal to P and Q is extension of not P implies Q is true. That means we assume that it is true. Since we assume that it is true and it's our hypothesis, we are going to prove it that it is true. So since this not P implies Q is equal to P and Q is logical implication. It's not logical equivalent, it's logical implication. That means it is grace. It says that the left side of the equation is superset of the right side of the equation. That means it is the right side of the equation that proves the left side of the equation. You say it's extension of P and Q. Since it is grace, you are going to transform it to a conditional statement and it will still preserve truth. If and only if not P implies Q, P and Q implies not P implies Q. We have now transformed it to conditional statement. You have now transformed it to conditional statement. Now, whenever antecedent is true, the consequence must also be true. So if you validate this statement that must be anything positive, always truth, you say that statement is tautology. Since there are no possibility of getting positive, whenever we validate this statement, we always get to say that it is statement is tautology. Is tautology. Being justified by logical implication. Being justified by logical implication. If and only if, since this question statement P and Q implies not P implies tautology, we then deduce that this P and Q is a proper implication of not P implies Q, the antecedent. So if it is true that P and Q is a proper implication of not P implies Q, we say that it is certain that P and Q exist. And if we say that P and Q exist, we then say that P and Q is logical implication of not P implies Q. I mean the consequence. P and Q is logical implication of not P implies Q. See, this is true that P and Q is logical implication of not P implies Q. Also, this also must also be true. If and only if P and Q is equal to P and Q. Sorry, we can't get it like this because we want to prove. Sorry, we want to prove that from this not P implies Q, we then prove that it is equal to P and Q is a section of P and Q. So we are going to deduce that not P implies Q is logical consequence of P and Q. Since it is tautology, we then deduce that not P implies Q is logical consequence of P and Q. That means this not P implies Q contains P and Q. Is a superset of P and Q. So since this statement is tautology, this conjecture is tautology, we then deduce that not P implies Q is logical consequence of P and Q. Since this is true that P not P implies Q is logical consequence of P and Q. Also, this must also be true. That means not P implies Q is equal to not P implies Q. So it is true that the logical consequence is equal to itself because whenever not P implies Q, and the left answer of the equation is true. Also, not P implies Q, and the right answer of the equation is also true. In the same vein, whenever not P implies Q and the right answer of the equation is false, also not P implies Q and the left answer of the equation is also false. You say it's logical equivalent. So it is true that P not P implies Q is equal to not P implies Q is a logical equivalent being justified by identity, the sameness. Being justified by identity. Being justified by identity. You can to this side. If and only if not P implies Q is equal to not, we are going to simplify this statement. This not P implies Q. It is a positive statement. It is a positive statement. We are going to negate it. We are going to negate it. If you negate it, it's going to be not bracket. And also, if you negate statements, also negate every other statement that is involved in that statement. That means you're going to negate not P and also Q, as not P and also Q. So, since it is not P, it's going to be P implies Q, it's going to be not Q. You have now negated it. And you see that it's no more logical equivalent. The right answer of the equation now is microcosm, that is subset of the left answer of the equation. So it's no more equal. The right answer of the equation is now less than the left answer of the equation. It say is extenuation of the right answer of the equation. That means is extenuation of not P implies Q. Being justified by signification of law. Being justified by signification of law. If and only if not P implies Q is equal to not bracket. Now let us transform this question statement to disjunctive statement. The its equivalent, the its logical equivalent is to disjunctive statement is going to be not P or not Q. That is the its equivalent, its logical equivalent. So you're going to substitute this logical equivalent in the disjunctive statement. That means not P or not Q. And it's still extenuation. Extenuation of not P implies Q. And it's being justified by first education law. It is two first education law that will transform P implies not Q to not P or not Q. Being justified by first education law. If and only if not P implies not P implies Q is equal to P and the Q. You see that you have now these statements, not bracket, not P or not Q, has now displayed with P and Q. That means the its logical equivalent is P and the Q, being justified by the Morgan's law. Two Morgan's law that we substitute P is two Morgan's law substitute not bracket, not P or not Q with P and the Q. And you see that it's still explanation of not P implies Q. You say is extenuation of not P implies Q, being justified by the Morgan's law. By the Morgan's law. You have seen that you have now proved the converse. That means not P implies Q is equal to P and the Q is a selection of not P implies Q. That means you have now proved it. That not P implies Q is equal to P and the Q is a selection of not P implies Q. You have now proved it. We say thus not P implies Q is equal to P and Q is extenuation of not P implies Q. So having proved the converse, you have now proved the converse. That to say that P and Q is equal to not P implies Q is a selection of P and Q is logical equivalent to not P implies Q equal to P and Q is a selection of not P implies Q by the principle of intentionality. We have done principle of intentionality in our last tutorial, so we can go back to be acquainted with the principle of intentionality. So, by the principle of intentionality, we then establish, since I have not proved the converse, we then establish that P and the Q is equal to not P implies Q is intensification of P and the Q. We then conclude, say, therefore, P and Q is equal to not P implies Q is intensification of not P implies Q. Is Christ the Almighty God's grace? So, since we have now established that P and the Q is equal to not P implies Q, is intensification of not P implies Q. Intensification of P and the Q is intensification of P and the Q. So he said that then Christ the Almighty God's grace exists. So, and this is a typical example of Christ Almighty God's grace. That is, P and Q is equal to not P implies Q. Is the of P and Q is Christ Almighty God's grace. We have now proved that Christ Almighty, God's grace exists. So at this juncture, we shall draw our curtain. Thank you, viewers.